Good morning, everyone. I am Laurent. I am in the Bazel team, and I work mostly on Skylark. So I will give some overview of what are the features in Skylark and what we are going to do next. So the new features. So where we are. So Skylark is designed to be just a simple language to extend Bazel. So the language is used in both build files and Bazel files. The syntax is a subset of Python, so it should be familiar to most people. In general, people like to read Python code and find it readable. And it is thread safe by design. So unlike many languages, so we have this feature by whenever a data structure is shared, it gets frozen. It becomes immutable. This enables us to evaluate a lot of code in parallel in many different threads and to reuse the results. When a Bazel file is loaded first, we cache the result and we can reuse it many times because we know it will never change. It's schematic by design, so you cannot access things from the from the operating system, so for the files, network, and so on. And it's deterministic by design, so whenever you evaluate the code, it will always return the same result. So this is guaranteed, and all these properties are very important to us because we want reproducible builds. So whenever you build your code, you want to get the exact same result at the end. So with Bazel, not everything is fully reproducible all the time because of the execution phase, but at least in the evaluation phase, we have this guarantee. So we have build files. Build files are intended to be simple and descriptive. It's a high-level representation of your project. So what are the targets? What are the binaries? What are the libraries? What depend on what? So it's very high level, and it's intended to be readable by both humans and tools. So normally, when you look at a build file, you have an idea of what's going on and how the project is structured. It's also important for tools because we want tools to be able to read and understand the build file as well as a human. This is super important to enable us create tools on top of Bazel. And the build files should also be writable by tools. Ideally, tools would take care of your build. Like there was a presentation yesterday about Bazel. You just run Bazel, it will generate your build file. You never have to look at it, and it just works. So it's not that great for every language, but that's the goal. So ideally, we should be able to generate build files automatically. Or if we have some IDE integration in the future, IDEs should be able to update the build files whenever you add a file in your project. And so build files are just the high-level description. So just some example from Scala. Even if most of you haven't used the Scala in Bazel, you can understand what's going on because it's consistent with the rest of the rules. You could have Java library instead, it would just work the same. And in Bazel files, we have the actual logic. So Bazel files describes the rules and the macros. And so it just the explanations, all the details of how the build file actually works. And so rules as a way to support new languages and new tools. And when I mean languages, so it's not just computer languages, just like C++ or Java, but you can imagine lots of other tools. Like if you want to generate a LaTeX document, you could just put your source file there, and it will generate a document. Or you could have some rules to create data. Like if you have a video game and you want to generate some of the images in different sizes, or if you want to generate anything, you can use rules for that. And some macros are just a lightweight mechanism to encapsulate existing rules. So normally, if you want to do anything complicated, don't use macros. So macros are just It's just convenient, but just be careful because it doesn't scale well. And users are often tempted to create lots of macros to simplify their build files, but it's often more difficult to maintain the files after that. So ideally, you just keep your build files simple, and even if they are repetitive, it's fine, because when you look at the build files, you can just instantly understand it. If you try to factor everything and remove every duplication, then the build files suddenly become more complicated to maintain by humans and especially by tools, because tools would have to evaluate your functions and understand everything. And so in general, just keep your build files simple and avoid too much abstraction. So yeah, just an example of macro. Yeah, in the documentation. So rules work by so here we have a simple build file. So just imagine that the library and binary have some sources and some other attributes. And so Bazel will generate an action graph. So this is the expansion of the CC library. It will run two commands to call the C++ compiler. This will generate two .o files, and then it will link in a library that you can use. And when we evaluate the CC binary, so CC binary will also have some compilation step and linking. But you notice the error between the two, because the CC library sends information to the CC binary. It tells that it will generate a libutil.h, and so there's communication between the two. So for communication, we use providers. So the rules define an interface for the user. So here the interface is just to say the rule has two attributes, sources and depths. The sources is just a list of .py files, and the depths are some targets that will provide a Python info provider. So this is really the interface of the rule, what the rule accepts. And then once you have your interface, your rule can provide information to other rules, just like in the CC library example. So to provide information, we use a provider. Here we create a Python info and say that every Python info has one field, transitive sources. You could have more attributes there. And you could also document them. So instead of the list, you could have a dictionary, and each attribute has some documentation associated to it. And in your implementation function, you just return the list of everything that your function provides. And once you have your interface and your providers, you can generate actions. So here is, in this example, we just run a shell command. Yes, just put what you need here. But that's really what a rule has to do. It's communication with other rules and generating actions. And then we can look at the rule performance. So the idea is that evaluating functions should be fast. Typically in your dependency graph, you have many targets. Each target should be analyzed very fast, and we analyze every target in parallel. And to keep the implementation function fast, the goal is to so the function can look at the list of attributes and see what are the list of sources or what are the dependencies, because that's the direct inputs. But it should not look at the indirect or transitive inputs. Like, for example, if we have some library that gathers all the transitive dependencies from all its dependencies, you end up with a huge set of dependencies. And you don't want to iterate over this set of dependencies because it would get slow. You don't want to expand it to a list. So the idea is that we have a data structure called depth set, which is optimized just for merging things together. It's just a one operation to merge all the dependencies together, and you don't have to iterate over it. So use depth instead of list if you want to gather dependencies. And then you have also other tips, like we recently added so some functions to generate the command line. So because when you gather all your dependencies in a depth set, you don't want to expand the depth set, or you don't want to iterate over it in the analysis phase. But you still need to generate your command line. And so if you use this cjs.actions.args, it's just a lazy data structure that will get expanded in the execution phase. So you don't expand the depth set during the analysis. Just only check the execution if you really need to execute this action. And yeah, if you care about performance, just use a profiler. And so I've put a link here. I will just go through a few examples to profile the code. So if you run these two command lines, you will get some information about the Skylark code and which functions take time. So here is just a summary to see if a build takes more time in the loading phase, analysis phase, or execution phase. So here you see that the loading phase is quite fast. So it's probably not the part you want to optimize, but you might want to look at the analysis phase and obviously execution phase. And so if you run this command, it will generate a huge HTML file which contains some useful information. On top of that, we recently added other commands. So here we use a startup flags macro. So just look at the documentation to see how to set up this. But basically, you can get the memory usage of your build. So you analyze your targets, and then you see how much memory it's using. Of course, this number is useful, but you want more fine-grained information. So you can use this command with dump -- rules, and you see how many rules are used in your build. So for example, you can see that there are 33,000 gen rules in this example. And you can also see the number of actions, because some rules generate one action, or many actions, or sometimes zero. So here you can see that proto library is generating a big number of actions. And you can also have more fine-grained information. So here it's using a pprof tool, and then you can see in which lines the targets are generated. So if something is using a lot of memory, you can just look at the Bazel file and see which place it's called. So I told you about the providers, and everything was great if you use only the Skylark rules. Unfortunately, for historical reasons, we have lots of rules implemented directly in Bazel. We call them the native rules. And the native rules don't always provide a good interface. So the goal for native rules is to enable this scenario. For example, you have a Java library, and you want it to depend on a Skylark library that you write. So instead of Skylark library, you can imagine any JVM-based language. And then your Skylark library should be able to depend on the Java library. So to implement this Skylark library, you need to access the providers from the top library, and then you need to pass information to the bottom library. And so this works in Java, and there's a nice blog post by Irina. It will tell you how to interact with the Java rules. And the goal is later to enable the same for other languages. So it's not perfect everywhere, but we are working on it. On top of that, we have aspects. So I think Dimitri will tell more about it, or if you have any. Yeah. If you have any interesting question, just ask Dimitri. He loves to talk about it. But the main idea is to be able to augment the dependency graph with additional information, so providers, or generate more actions. So if you have a dependency graph like this, so you have a target X with multiple attributes, and so if you go through, if you work along the depths, you can generate a new graph by applying a function on every node that is in the depths. And so this is very useful to get some information about the graph. For example, to enable ID integration, you might want to walk over the graph, get all the information about your build, and pass information to the ID. Or you can also decide to run some actions in some targets. And just a few things of what we are doing or what we want to do. So there's a Skylib, which we open sourced recently. It's just a collection of useful functions because we noticed that many people need the same functions, so we should just put them in a library. So here you can see some functions with path manipulation or quoting some string to pass it to a shell. So if you write complex rules, you probably want to take a look at Skylib. It's still very new, so please ask for more functions, or yes, just send requests. It's still quite small. As you notice, we are doing a lot of changes in Bazel, and I know that some people complained about it yesterday. So we added a flag -- all incompatible changes. So the idea is that when we do some backward incompatible change, we first put it behind a flag so that it's not enabled, but it allows you to try it. So if you build your code with this flag, it will try with the future changes, and it will allow you to make your code compatible with the future Bazel version. And then in the future, we swap the default of the flags. So if you didn't update your code and you get the new Bazel version, you can still get the old behavior for some time until we definitely remove it. And so yeah, the goal for us is to put all backward incompatible changes behind this flag. In practice, we don't always do, but we try. So just tell us if we don't do it correctly. We also want to provide more guidelines. We know that writing rules can be a bit complicated or confusing, and so we wanted to give you more information about it. So we have 2 style guides in the documentation. This is something that we want to improve and extend. So if you have any questions about the style, just ask us, probably on Stack Overflow or on the mailing list. And this feedback is very useful for us to improve the documentation. There was a presentation yesterday about the linter. So this is something we recently published, and the goal is to add more checks in the linter. And for testing, we also want to publish more guidelines. We know that testing the Skylark rules is not always easy or as good as you would like, but so we're going to work on it and publish more guidelines. There are lots of Skylark rules. So if you check on GitHub with just this search request, you will find like 120 Skylark rules, and and people write new Skylark rules all the time, so it's increasing quickly. And so ideally, we would provide a way to highlight which Bazel rules are well written, or also, so it's not completely clear, but we would like to, yes, just to show which rules are reliable, updated, maintained, and comply with the guidelines. Um, some also, so when you modify the Skylark code, many people use a Python mode in their editor. But ideally, we would have better support for modifying a Skylark file. And so one solution to do that is to implement the language server protocol from Microsoft. This is something that many IDEs implement. So if you implement support for Skylark, it will be useful for many IDEs, for example, a Visual Studio Code and stuff like that. And so with the language server protocol, we can have many IDE features like code completion or go-to definition and all these kind of things, and the tooltips and see the documentation and so on. So this is something that we would like to do, but we're not working on it yet. So if anyone is interested, just let me know. For ID integration, we also want to have a debugger to debug the Skylark code. So someone made this prototype, and I think it already looks really great. So you have the Skylark code on the right, and you can put breakpoint on your code, and then you can see the list of all the local variables or all the definitions and explain everything. So here you have a depth set, and you can see every element in the depth set. So this is something that is not published yet. It's a work in progress. It should be available soon. And so this is integration in VS Code. Ideally, we would use the same protocol to add support in other IDEs. And yeah, there are more potential tools that we would like to have. But for example, build file generation. So there was a talk about Bazel yesterday. So ideally, we would have this kind of tool for every language or everything you want. Just tools that will update and maintain your build files so that you never have to look at them again. And well, so it's a bit related, but it would be nice also to have strict dependencies for all languages. So someone mentioned yesterday that users will always add the dependencies when they need them, because otherwise it doesn't build. But they always forget to remove them because, well, it still builds. So they don't. It can be difficult to know which dependencies are not used when you just look at the build file. So ideally, that's a job for tools to detect what is needed and what is not. And if you remove all the unneeded dependencies, it can speed up your build a lot. I mentioned yesterday Buildifier that formats the build files. Ideally, we would have the same for Bazel files. You just type your code, you run the tool, it will format it nicely, and you don't have to care about indentation or spaces or this kind of things. And once you have this code formatter, you can build a lot of refactoring tools on top of it. Just like I mentioned Buildozer yesterday for build files, you could imagine refactoring tools for Bazel files. So if you rename a function or this kind of things. And yesterday, someone told me that they would like to have some kind of type checking for Skylark code. I think that's something that could be potentially integrated in the linter. So we're not going to have static typing, but in some cases, you just can analyze the code. And when you have type information, you can propagate it and see if there's a type error. So it will never catch everything, but maybe it can be good enough to be useful for users. And so, yeah, so I think the goal is to build an ecosystem on Bazel. So for the Skylark team, there are really two goals. First is to enable you write high-quality rules for every language you care about. And the second part is high-quality tools. So we want tools to manipulate the build files. We want tools to analyze the build graph. For example, you can use a Bazel query to have some information about the graph. Or you can use aspects to get also some information about the graph. And since we provide you a lot of information, you can easily build tools on top of that will analyze the graph and maybe suggest some transformation in the build files. Like this target should be split because it depends on a lot of things, and it will make the build faster. Or there are lots of things that which you can do once you have access to the build graph. We also want to enforce conventions, and I think that's something very important when you have a large code base. If you have conventions for every languages, it makes everything much simpler. So yeah, the goal is to make your code base scale. So yeah, that's really the two important things for the Skylark team. Enable you write good rules and enables you write good tools. Thank you.